All right, good morning, pre-calculus class, and today we are going to talk about some restrictions on our domain, and this is the final new thing in chapter 2, okay? So remember, our test is this Friday, and also all missing work for chapter 2 is due by Sunday, so make sure we're wrapping this chapter up if you're behind over the next 2 days as we review for the test. You also need to get in any missing work, okay? Please reach out to me if you have any questions about that. So today we're going to talk about what are the two restrictions on the domain. Now hopefully you guys remember our domain is our x values, okay? So what are the possible x values that can satisfy a function, that can go into a function? So what are the two things we cannot do in math? And hopefully you guys remember we can't have a square root of a negative. Now this one's a little loaded because we can take the square root of a negative, but it results in a imaginary number, and for our function we can't have that. So you can't have a square root of a negative, and then you also cannot divide by 0. And you can't divide by 0. So two things we can't do, and they will result in some problems for us if we try to do them. So restriction number 1, we're going to start with that second one I wrote. So can't divide by 0. And what that means is the denominator cannot be equal to 0. Remember, numerator's on top, denominator's on the bottom. So in our case here, since x plus 3 is the denominator, we can set that equal to 0, subtract 3 over, and we know it can't be equal to 0. So it cannot be equal to negative 3. As long as x is not equal to negative 3, we are fine. Now, the way we want to write this, down here at the bottom, if there's no restrictions for us, our symbol for that kind of looks like that, or sometimes you might see it like this, like an R with an extra line on it. And what that stands for is like all real numbers. So all our numbers, whether they're big, small, positive, negative, decimal, or whole number, okay, all real numbers that we have. So the way we would write this, our domain for example 1 is all real numbers except x cannot be negative 3. That's how we'd read that. So some of you might be thinking, okay, now what about x plus 5? That's on the numerator. Since it's on top, we don't care if that's equal to 0. If it is, then our y value or our output is 0, and that's okay. So now example 2, same approach. We're going to say x minus 2, the denominator cannot be equal to 0. So to solve it, if we add 2, x cannot be equal to positive 2 there. And it can be all reals except x cannot equal negative 2. So we always need to check if there's a denominator, we need to check that to make sure there's not a restriction on our domain. Now, a second restriction that we already kind of talked about is we can't square root a negative All right, so we know if there's a square root involved, the square root has to be greater than or equal to 0. We can take the square root of 0, but it has to be greater than or equal to 0. So if we look at this one, our x plus 2 is inside the square root. In order for this to be a true statement, we know that x plus 2 must be greater than or equal to 0. Then we're going to go ahead and subtract 2 here, subtract 2, and we get that x has to be greater than or equal to negative 2 in order for this to work. So our domain, in this case, can be all reals except x must be greater than or equal to negative 2. That's how we'd write it. Now number 4, same approach, a little more complicated, a little bit more we're going to have to do. Remember 3x minus 12 must be greater than or equal to 0. Okay, so add 12 to both sides. 3x has to be greater than or equal to 12. Now we divide by 3. X must be greater than or equal to 4. Some of you might be tempted to flip that sign. Remember, we only flip it if it's divided by a negative. So in our case, it stays. So x has to be greater than or equal to 4. So once again, all reals except x has to be greater than or equal to 4. All right, now finally, what do we do if the square root is on the bottom? So if that's the case, if both of these restrictions occur, we'd have 1 over the square root, and that has to be greater than 0. Because remember, normally with the square root, it has to be greater than or equal to 0. However, our square root on the bottom cannot equal to 0, or else that's a problem. So now, example 5 here. We look at it, and we set that x minus 1 has to be greater than 0. Add the 1, add the 1. X must be greater than 1. So to write this, it can be all reals except x has to be greater than 1. And now for this final one, we'll do 2 minus x has to be, oops, I wrote the wrong thing, has to be greater than 0. So it's up to you on how you solve this. I'm going to choose to keep the x on the left side. So then we're going to have negative x is greater than negative 2. We divide by our negative 1, and this is what I was talking about. If we divide by a negative, then the sign flips, so x is less than 2. Okay, and that can be all reals except x has to be less than 2. All right, and then finally, sometimes there's no restrictions. So here, x plus 11, I'm sure some of you are going to be tempted to say, oh, it can't be negative 11 because we set that equal to 0. But remember, that's just a case. If we get 0, if x is negative 11, we get 0 as our output, that's fine. 0 is an okay output. We just can't get 0 on the bottom. Okay, so this one, we would just put that r, it's all reals. And the final one, 3x squared, once again, we can have any value go in for x, and it won't screw us up. So all reals. All right, so flip it to the back, and sometimes we're going to have to do some graphs with this. So if we look at this one, this was our original square root graph, except it's shifted now, and it's x plus 7. So we know it's shifted 7 to the left. So in red here, I'll draw the original parent function, 0, 0, 1, 1, 4, 2, and then 9, 3. And we're shifting it left 7. So each of these points is going to go left 7. And if you want, you could even add some other points because it does keep going. However, we're going to stop there. Now, I want to talk about, oops, I did not mean to do that. Here, this one. So I wanted to talk about if we had x plus 7, remember it has to be greater than or equal to 0. So x plus 7 must be greater than or equal to 0. We subtract the 7. X has to be greater than or equal to negative 7. So our answer for the domain is all reals except x has to be greater than or equal to negative 7. And so I put that in a box. So what that means is if you look over here, hopefully you can see that the only values that will work for this, because the square root stops over here when it gets to negative 7, what I mean right there. Okay, the only values that work for x are when it's positive, or when it's greater than or equal to negative 7. When it goes this way, it can go as far as we want this way. However, it cannot be less than that. Okay. So, on our next one, and we briefly talked about this when we started with this reciprocal function, but we know the original one kind of looks like this. at 1, 1, and negative 1, 1. Or sorry, negative 1, negative 1. And in our case, it is going to shift right 2. So I'll do this one in red. Let me erase that quick. If it shifts right 2, here we go, and it's going to look like that. And this line right here that we avoided of positive 2, the reason that has to be avoided, remember that x minus 2 cannot be equal to 0. We'd add that 2 over. We find that x cannot be equal to 2. So that dotted line I drew in, that is y. So the way we write that now to finalize that is all reals except x cannot be equal to 2. All right, so we've got 2 more, and this one, x cubed minus 4. We know that's going to go 4 down. So let me draw the original here, 0, 0, 1, 1, 2, 8. And then likewise, negative 1, and negative 2, negative 8. And if everything shifts down, 4. And one of these is going to be way down there. You don't have to draw it all the way down. You can just have it kind of go off. But as I erase these now, we just draw this in. And as you can see, there, since this continues forever, I know it's very small, but it technically keeps expanding and getting wider and wider. So all the possible x values would work for that. Okay? There's nowhere where that cannot exist. Now you might have to go like up to a y value of like 5 million, okay? But it keeps getting wider and wider out to each side. So our answer for that one for the domain would be all reals. Okay, and now our final one. This one is, once again, I'll draw the generic version. So 0, 0, 1, 1, 4, 2, and 9, 3. And once again, that keeps going. Okay, we'd also have like 16, 4, etc., etc. But we see here, this negative out in front means it's going to flip up and down. And the x minus 4 will make it go right 4. So if we flip it and right 4, that 0, 0 is not going to change. However, this one would have been up here. Now it's going to be flipped, so it's down there. This one would have been up there. Now it's flipped. So it's there. And there's also a point here. It keeps going out. So let me erase that, and it would look roughly like that. Okay, now, to understand this one, remember, x minus 4 had to be greater than or equal to 0. So if we add the 4 over, add the 4, x must be greater than or equal to 4. So our answer, all reals except x must be greater than or equal to 4. So that's all for today. Tomorrow we're going to keep reviewing this concept and get ready for our test. You'll have the review to work on. Anything from Chapter 2 you need to finish up, because remember, our test is Friday. Please let me know if you have any questions, and I will see you guys tomorrow in class.